Old Grumpy Hunter here. Christopher Columbus showed us that the world was not flat, but neither is it round. The Earth's surface is irregular, and eventually you as a crossbow hunter will be shooting up at a target or down and at angles that are quite steep. Uphill or downhill shooting steeply presents some challenges. Your shooting form is going to be off because the targets are almost right below you or up the hill from where you stand. The elevation alters the shooting range, and that affects which reticle or dot to use. We're talking about crossbows here. The guys and gals that can't miss at that 3D target on flat ground will be throwing a curveball when shooting at angles. So how do you compensate for the difference in elevations? It's logical to lead a moving target and aim into a crosswind, but to use a lower reticle or dot when shooting beyond your zero distance? But what about shooting up and down? Many archers find the concept contradictory. It's the opposite of what your mind is telling you.
When sighting in your bow over flat ground, without knowing it, it creates an arc of some type. But when shooting up or down, a slightly different arc is needed. Arc of the arrow crossing flat ground to the target will not put the arrow exactly on target when you are aiming significantly uphill or downhill at the same distance. The effect of this error increases with distance and steepness of the angle to a maximum of 60 degrees. This error applies to both shooting up and downhill. Either shooting up or down, you must aim low to hit the target if you're going to shoot the actual distance. What? There are three distances when shooting up or down: vertical, horizontal, and actual.
Overestimating the sharpness of the angle is a problem. You need to be exact as possible. The point of aim is determined by the up or down angle and the horizontal distance to your target. The point of aim compensation increases significantly with distance and steepness of the angle to a maximum of 60 degrees either direction. Gravity is pulling everything down at about 32.2 feet per second. It's working on the arrow the moment it leaves your bow. The effect of gravity is greatest when shooting horizontal than shooting at an angle. You shoot your crossbow being perfectly level and drop the weight of some type at the same time, both will hit the ground at the same time. The same is true with a bullet and an arrow. If both are fired at the same time, the arrow and bullet will hit the ground at the same time. Of course, the bullet will have traveled much farther downrange. Because you're not using proper form, many crossbow hunters will miss when shooting uphill or downhill. As soon as you have to aim uphill or downhill, your form changes. This change in form affects vertical bow hunters more than it does crossbow hunters. If you're going to use a tree or ladder stand to hunt from, practice from it. If you're using an elevated box blind, do the same thing. When shooting uphill or downhill, you need to know the actual distances to your target. This is because the actual distance will always be greater than, or maybe equal to, the horizontal distance to the target. When shooting uphill or downhill, the actual distance to your target is solved by a mathematical equation of the vertical distance squared equals the actual distance squared minus the horizontal distance squared. You can solve the actual distance by the following equation. The actual distance equals the square root of the sum of the vertical distance squared plus the horizontal distance squared. You can solve the horizontal distance by following the equation. Horizontal distance equals the square root of the actual distance squared minus the vertical distance squared. Anyone have the calculator handy? When you shoot down from a tree stand or up from a gully, the actual distance of the shot is longer than your aiming distance. This is because you're shooting the hypotenuse of the two legs of the triangle, and this can add up to as much as 40% to the shot distance for some extreme shots. Looking at two examples, we see that in example 1, you're up a tree 5 yards and the deer shows up 13 yards away on the hypotenuse with the sloping side of your triangle. How far is the horizontal distance? Using the formula I spoke of earlier, h squared equals a squared minus v squared, we get h squared equals 13 squared minus 5 squared. H squared equals 169 minus 25. H squared equals 144. The square root of 144 equals 12, so h equals 12. Looking at another example, you're up a tree 6.6 yards The deer is 2.3 yards away from the base of the tree. What's the actual distance of your shot? Rearranging the formula to a squared equals v squared plus h squared, a squared equals 6.6 squared plus 2.3 squared, a squared equals 5.29 plus 43.56, a squared equals 48.85, the square root of 48.85 equals 6.99, a equals 6.99. In the two examples just given, what distance do you aim at? Example 1. Do you aim at 5, 12, or 13? Example 2. 2.3, 6.6, 6.99. Wait a minute. In both examples, the aim distance is shorter than the actual distance. How can that be? You always aim for the horizontal distance when shooting up or down. In the first example, we're only talking about 1 yard, but that 1 yard can result in a high point of impact or a miss depending on how fast the deer reacts. In the second example, if you shoot the actual distance, you will shoot over the deer a long ways, even if the deer does not move. There used to be a YouTube video where the hunter used up all their arrows. The hunter was shooting the actual distance and shot over the deer every time. That would be like the situation in example 2. A table available online that has all the calculations done for you. I'll provide a link in the video description, and a link will be on the Old Grumpy Hunter website. But how many of you want to pull a paper out of your pocket just as that trophy buck is standing there? There's a rule of thumb that can be used. It's based on the 3 angles of 30, 45, and 60 degrees. For 30 degrees, you aim as if the target is 10% closer than the actual distance. 45 degrees, you aim as if the target is 30% closer. And at 60 degrees, you aim as if the target is 50% closer. Remember, these numbers are a rule of thumb, and you might find them to be off a bit. So based on the rule of thumb, if your target is 37 degrees, the actual distance is 30 yards, what would be your aiming distance? Mathematically, on a linear scale, it would be 24.2 yards. 0.2 of a yard equals 7.2 inches. The best way to get the true shooting distance is to use a rangefinder that automatically calculates the distance based on the actual distance and the angle of the shot. Furthermore, I suggest that you measure distances to different objects like trees, stumps, bushes, etc. every time you get into your blind or stand. That will refresh your memory as how far everything is. When shooting from above or below, you need to change your point of aim in relationship of both vertical and horizontal center of the vitals of the target. What does that mean? Basically, if you aim for the same spot of the deer you would when it's at the same level as you, you're most likely not going to have a lethal shot. To demonstrate this, let's use this box and arrow. The red cross represents the center of the vitals, and the red dot is your normal point of aim when shooting at the same level. I'll give examples of 30, 45, and 60 degrees, as well as the 2 scenarios discussed before. In all these examples, your target is standing broadside. When you are level with the target, your shot is going to look something like this. The 30-degree shot. This first view is aiming at the same spot as level. Compensating for the angle, the arrow goes through the center. At the 45-degree shot. This first view is aiming at the same spot as the level shot. Compensating for the angle, and the arrow goes through the center. And at the 60-degree shot, this first view is aiming again at the same spot as level. Compensating for the angle, the arrow goes through the center. Let's take a look at the 2 scenarios I discussed above. Example 1 is very similar to the 30-degree shot previously seen. The angle is closer to 23 degrees. The second shot goes through the vitals. 2. This one's the most severe angle. It's close to 71 degrees. This is what it looks like if you adjust your shot. Earlier I said you need to aim lower when shooting up or downhill. Then I just used the box and arrow and implied you need to shoot higher. What's going on here? First of all, they're 2 different concepts while being related concepts. Second, when talking about shooting lower, that pertains to when you're shooting the actual distance and don't know the horizontal distance. Remember, you need to aim for the horizontal distance. Third, With the box and arrow, yes, I know that deer and other animals are not square, but I was trying to demonstrate how you need to adjust your point of aim and hopefully your point of shot due to the angle of the shot. To better understand this concept, I suggest you view the videos on YouTube from Masterpiece Archery Targets with Brian Johnson, especially the following videos of deer anatomy, center kill, and circle kill. A link will be in the video description. In a nutshell, there are two things you need to do when shooting up or down. Aim for the horizontal distance, compensate for the angle by aiming for the center of the vitals. Thank you for watching this Old Grumpy Hunter presentation. Please give it a big thumbs up. And if you haven't already, please subscribe to my channel and don't forget to push the notification bell.